Sir Isaac Newton was a brilliant polymath who dedicated much of his life to helping shape the way we understand the universe. In this video, we will cover some interesting facts about Newton, his work, and his laws of motion. Isaac Newton was born in 1643 in England, and throughout his life he contributed to many fields of science. He was a mathematician, a physicist, an inventor, an author, an astronomer, and even an alchemist. Talk about productive. In the field of optics, Newton demonstrated that white light can be split into a spectrum of colors. In the 1660s, he used a device called a prism. The prism causes light of different colors to be refracted by different amounts and to leave the prism at different angles, creating an effect similar to a rainbow. Newton identified 7 colors in the visible spectrum: red, orange, yellow, green, blue, indigo, and violet. In 1704, his work on light was published in his book called Optics. Thanks to his studies and understanding of light, Newton built the first practical reflecting telescope in 1668. A reflecting telescope uses a curved mirror to gather and focus light, whereas a refracting telescope uses lenses. Newton's design helped solve some of the optical problems found in earlier telescopes and became known as the Newtonian telescope. Perhaps Newton's most influential contribution was his formulation of the 3 laws of motion. These laws describe how objects move when forces act upon them and form the foundation of classical mechanics. The first law states that a body at rest will remain at rest, and a body in motion will remain in motion at a constant speed and in a straight line unless acted upon by an external force. This law is often called the law of inertia because it describes an object's tendency to resist changes to its state of motion. Let's put it to the test. If I leave this ball on the ground near the Claddagh area, it will remain at rest unless an external force acts on it, such as me kicking it away or simply picking the ball up and taking it home. Newton's second law of motion states that the greater the mass of an object, the more force is required to change its motion. This law is expressed by the formula F equals ma, where force equals mass multiplied by acceleration. The second law tells us something we've all experienced. Heavier things are harder to move. To demonstrate this, I'm going to flick a coin across a smooth surface, making sure I don't scratch the surface. The coin will accelerate and move across the surface. If I apply the same force to a heavier coin, it will accelerate less because it has more mass. The third law is one you've probably heard before. For every action, there's an equal and opposite reaction. If I push against this brick wall, the wall pushes back against me with an equal and opposite force. Okay, but how does this law apply to smaller objects? Let's say I push a leaf in a flower pot. Does it push back on me with an equal and opposite force? The answer is yes. The leaf exerts an equal and opposite force on my hand. However, because the leaf has such a small mass, that force causes it to accelerate much more than it causes me to accelerate. That's why the leaf moves away while I barely notice any effect. Where do these laws of motion apply? Do they apply in everyday life? Are the laws the same in space? The short answer is yes. Newton's laws accurately describe the motion of everyday objects and are still used today in engineering, construction, transportation, and even spaceflight. However, in situations involving extremely high speeds or very strong gravitational fields, Newton's theories are no longer completely accurate. In the early 20th century, Albert Einstein developed the theory of relativity, which refined our understanding of space, time, and gravity. Einstein showed that gravity can be described as the curvature of spacetime rather than simply a force acting at a distance. As physicist Richard Feynman wrote in his book 6 Easy Pieces, Newton's law of gravitation is not correct. It was modified by Einstein to take into account the theory of relativity. Newton's laws remain excellent approximations for most situations, while Einstein's theories provide a more complete description of the universe under extreme conditions. To summarize, Newton's laws of motion, published in 1687, are still used extensively today. For most everyday situations and many engineering applications, Newton's laws provide extremely accurate predictions. However, when dealing with objects moving closer to the speed of light or with very strong gravitational fields, scientists use Einstein's theory of relativity. One of Einstein's most famous equation is E equals mc squared, where E represents energy, m represents mass, and c is the speed of light. The equation shows that mass and energy are different forms of the same thing and can be converted into one another. What are some other interesting facts about Newton? Newton published several major books, including Philosophia Naturalis Principia Mathematica in 1687. This book laid the foundations of classical mechanics and presented the laws of motion and universal gravitation. Newton was not known as an effective teacher. Historical accounts suggest that his lectures at Cambridge were often sparsely attended, and he generally preferred research to teaching. Newton almost became a farmer. During his teenage years, his mother removed him from school with the intention of having him manage the family farm. However, his teachers recognized his academic talent and persuaded Newton's mother to allow him to continue his education. He later attended the University of Cambridge. Newton also spent a considerable amount of time studying alchemy and wrote extensively on the subject, although most of these writings were never published during his lifetime. On the 31st of March 1727, Newton died in his sleep and was buried in Westminster Abbey in London, among kings, queens, and other distinguished figures. So what can we take away from all of this? Sir Isaac Newton wasn't just a scientist who supposedly got inspired by a falling apple. He was a thinker whose ideas changed the way we understand light, motion, gravity, and the universe itself. From explaining why objects move the way they do to building a revolutionary telescope, Newton's discoveries helped lay the foundations of modern science. More than 300 years after his death, his influence is still all around us. Not bad for someone who almost quit education to look after the family farm. Thanks for watching. I hope you enjoyed this video. Leave a comment if you have any feedback.